To help us understand kind of how to do this analysis of camera motion, let's look at some of the motion models. Now this will remind you of all the stuff that we looked at in one of the previous lectures about image transformations, where we were trying to model how an image would be transformed from one to the other. Now all of a sudden this should start making sense in the context of how we can do this with video. So here, for example, is a video that we're interested in. What we're interested now in is finding in this image, by these points moving around like this, what's the best possible camera motion in terms of a variety of degrees of freedom. And of course, we want to be able to model the least number of these degrees of freedom. Remember the degrees of freedom when we talked about image transformation? Well, the image transformation is from one frame to the other in the video volume, and we're now interested in finding out what those degrees of freedom are. Let's start off with, of course, the simplest one, translation. So here, of course, we basically are looking for a translation where the frame is just moving from one frame to the other in X and Y. If we just did this, this is a 2 degree of freedom. And here you basically see the example that I've just modeled the 2 degree of freedom. And if I was to show you the result of how the stabilized crop window would look like, that would be on the top here. And you see it has a little bit of wobble still, which suggests that just by doing a 2 degree of freedom transformation between frames here is not going to result in a very stable video. You can see the jerkiness in the middle of the video here, right? Of course, we have learned that when we can't actually model it with just the translation X and Y, we can also start thinking of adding rotation and perhaps scale into the equation. So let's do that. Of course, we can look at translation in X and Y, but also let's add uniform scale in both X and Y, and rotation. Of course, we know very well that that is basically a 4 degree of freedom, where now we have a theta, X and Y, and the scale. It's uniform scale, so it's the same in both. That basically suggests that now my crop window can rotate a little bit, but also can get bigger and smaller a little bit too. And that actually results in this solution here. Good, it's not very shaky, but still has a lot of little, wobble in the middle of the image. You can see this part shaking around. Of course, let's move to homography. We did all of this kind of stuff when we talked about image transformations again. In this case, we want to be able to translate the image from one frame to the other in X and Y, rotate and scale. But let's now add perspective and skew to the whole thing. That basically now means is now we have an 8 degree of freedom model. We remember that from our earlier lectures. And now I basically have a crop window that can also have a shear and perspective warping going on in addition to the translation and rotation. And this is the output. So if you notice, this looks much stable. So in essence, what we've done is now gone through the steps of identifying the camera path by looking at these degrees of freedom for this rectangular region, the crop window. And if I can figure out what those degrees of freedom are, I can actually start generating a new video just showing you the small region here, which is basically moving around in the larger viewpoint here. Again, remember, we are cropping the image, but of course, in this case, we're getting something nice in the output there.